A first-order differential equation is linear if we can put it in the form seen here. This is what we refer to as being the standard form of a first-order linear equation. And note kind of the defining characteristic of this standard form is the coefficient of the dy dx is simply a 1. The first step towards solving is to make sure you get the differential equation in this standard form. Once you have done so, we can focus in on this coefficient of the dependent variable y, the p of x. We use the p of x to form what we call an integration factor. So the integration factor is going to be mu of x is e to the integral of p of x. So finding or determining this integration factor is a computation that we do to the side. Once we have this integration factor mu, we simply take it and we multiply the differential equation by it. So each and every term gets hit with a mu of x. Now, note on the right, you've kind of made things more complicated. You would have mu of x multiplied by the f of x, which is there. But on the right-hand side, things actually simplify. What we've seen is that each and every time, that left-hand side will become the derivative of the dependent variable multiplied by the integration factor. And it always works out this way, so we will just jump to this. So the dependent variable multiplied by that integration factor mu. And then we simply have to recall what our goal is. We would like to somehow determine what is this function y. And now we see it appears exactly in one spot. So in order to get to this y and isolate it, we need to anti-differentiate. And that's really the process. So integrate, and then solve for y. So let's go ahead and look at a nice concrete example that illustrates this process. A very typical first-order equation is given here. And note, dependent variable y, independent variable x. The intuitive observation is that the dependent variable y is not appearing inside any other function, and the y and the dy dx are not being multiplied together. So this is most certainly a first-order linear differential equation. Linear being the key observation. In order to solve it, we need to get the differential equation into standard form. That means we need to divide each and every term by x to make our leading coefficient a 1. So dividing through by x, we are left with dy dx minus 1 over xy equals x sine of x. And this would be the standard form of this first-order linear equation. And recall, the coefficient of y in this standard form is what we use to form our integration factor. So our integration factor is going to be e to the integral of minus 1 over x. And this minus 1 over x, or what we referred to as p of x previously, must incorporate any negative signs as well. So evaluating this integral, we would have e to the minus natural log of x. And the simplification that we've seen many times is we now take this constant in front of the natural log, we make it a power, and once we've done that, the e and the natural log can cancel each other, and what we are left with in this case is just 1 over x. And oftentimes we make the choice not to worry about the absolute value present, and we just solve for when x is positive. So we now take our integration factor, 1 over x, and we multiply both sides of the differential equation by it. It works out great on the right-hand side. The x and the 1 over x cancel. And then on the left-hand side, just as nicely, remember every time we will have the derivative of the dependent variable multiplied by the integration factor. Now to get to our solution y, we need to integrate both sides. So on the left-hand side, the derivative goes away, and on the right-hand side, we have the antiderivative of sine. So y times 1 over x is equal to minus cosine x plus c. And note, this is a perfectly good implicit solution, but with this method of solving a first-order linear, we can always do one additional step to just isolate that x on the left and have a nice explicit solution.